To this Swift group learning session where we take a Swift concept and we learn in a group ensemble session on how to do it. In this week, we're going to be looking at rewriting some code written in the C language into the Swift programming language. This session is being hosted on the Swift Dev Chat Discord server. If you want to participate with suggestions and whatnot, I recommend you join the server and join us in the Discord call. We host these every once in a while to try and learn new concepts or try to explore new things in the wonderful world of Swift and development in Apple's ecosystems. So, without further ado, let's hop into it and let's see what we're looking at today. So, this is kind of a continuation from last week's session where we were trying to parallelize map tile rendering for the CubiomesKit library so that way we can generate Minecraft map tiles a little bit faster. Where we ran into a problem where we couldn't quite get it working under async await, but we realized we could probably rewrite this biomesToImage function, which is provided in the util section of Cubiomes, which actually takes the color data and the biome IDs, right, saying this is plains, or this is a desert, and it goes with this color. And taking that and actually generating the actual pixel data. So this is the function that we're going to be rewriting into Swift, in the hopes that we can then later parallelize this. So, I guess without further ado, let's see how we're going to go about doing this. Ugh. Lengthy introduction, I know. Now, normally the way that I start with these types of things is I want to write tests so I can verify that things work correctly. Problem is, I don't know how we're going to necessarily write these tests because I don't know what the actual output looks like to know how to deterministically do it, which is slightly problematic. So, Anyone have any ideas on how we could potentially scaffold that out, maybe, in terms of like tests, so that way we can just have something to let us know if we're in the right direction or in the wrong direction?
Do you mean in terms of validating that what we've created matches what the original function was doing?
Yes.
So like unit tests for it, or?
Yes.
Yeah, so I'd say just write some unit tests that pass in various data, ideally at the edges, and check the results. I mean, basically what you want is approval tests here, where it's like, given some data, here's what it produces.
Yeah. Well, I mean, I guess we could theoretically just kind of do a sort of pre-render thing. Yeah, okay. So we could just imitate a render and then just check that the things match. Yeah, that works.
I would say if you have the same inputs, I mean, can you just generate a hash and use the hash to compare or something from the data?
I don't know if you could do a hash from the data.
Because you can do a SHA-256.hash passing in a data stream. So.
We could see. I don't know. Let's get something running first.
Okay.
BiomesToImage generator tests. Import testing. We're going to need to import Cubiomes for this. At testable import. Well, CubiomesKit's going to already import the internal, so that's not actually necessary. I may need foundation. We'll see. Foundation. Thank you. Apparently, I do not know how to type. Func. Image generator. Matches. Utils. I think we can make this async, but I'm not sure. We will see. Is Minecraft world, I guess. Version, I think we can specify. This is not the initializer I want to use.
These are not the initializers you're looking for.
It's this one. Because that lets us bypass the string parsing. Let world is that. Let generator equal world.generator. We'll specify the yeah, we could do the nether. I think the nether would be slightly faster anyway.
It's smaller.
Yeah, because there's only like 5 biomes, so like that would be really easy. Get tiles in origin. What are we doing there? Get tile map origin. Well, we're not doing anything with center position, so that's fine. We can just open a new tab. Okay, so we could keep the rect is Minecraft world rect origin 0 scale squaring. We'll do 64. 64 blocks wide on each axis, except for Y. Y would just be 1 block because we're not trying to generate a whole 3D chunk. So then in our renderer, what is the next thing that we do after that? We create the biome lookup table. Using generator, XZ, and rect. Right, okay, so we need to create a range. Let CB range equal Cubiomes range scale for X rect origin X rect origin Z rect size width rect size length rect size height. No. Origin Y rect size height. I don't know why the Y parameters were put at the end of this. I didn't write that.
That is a little odd, but
yeah. Let biome
welcome to the world of C.
IDs equal. Well, that's more of a Cubiomes Cubitect decision, not a decision on our.
Sure, but I mean, it's been more than a couple decades since I last worked regularly in C, and I remember that you would end up with some interesting parameter orders because once you had a function with parameter order, you never wanted to change the sequence. So if you added parameters, so they probably started, oh, we just need the X and Z for this. And then later on, like, oh, I guess we need Y.
Probably, yeah. Okay, And then we just need to call gen biomes for generator, biome IDs, CB range. Oh, do I just need to, there we go. Okay, so that generates the biomes, we're good. Okay, get biome colors. We're not gonna be doing anything fancy there, so we're just gonna create a color group next. Color group is uint 8, uint 8, uint 8 is 0, 0, 0. Init biome colors into the color group. And then I think we have everything we need to pass information into the generation function, correct? RGB data, biome colors. Oh, never mind. We need to do this. Right, okay. So much going on.
It is a large and complex operation.
Yeah. Let image width equal, we'll just say 4 as the pixels per cell here. Rect size width. Let image height equal 4 times rect size length. Oh, do I have these properties backwards? Yes, I do have these properties backwards. You're supposed to be length. You're supposed to be width.
Why is height based on width?
Image height in 2D space is the equivalent of width in the Z axis because Minecraft is weird. Z is not up.
Okay.
Y is up,
fair
not
enough.
Z. That's not a decision.
Oh,
I made
yeah,
or
because Z
Cubiomes made.
is what comes toward
Yeah.
you.
Yeah.
Yeah, okay.
Yeah. I did not make that. That's on Mojang. It's perplexed us for decades.
Yep.
All right, so we need, for our RGB data is pixel image data. What are you? C unsigned char. Unsigned char. Repeating 0. Count. Right.
1,
Okay.
2, 3, 4. Oh, you weren't asking me to count. Okay.
Right, because we have to initialize the size beforehand, otherwise Cubiomes will scream. Okay, so I think this is where we can actually start branching off a little bit. So expected data is that. So then we can say biomes to image expected data biome, or this is the color group, biome IDs, rect size length, rect size height, and then this is uint 32. Well, we could just say 4 here. And then what is the last one? 2. Yeah, this little fella here.
Yeah, that's just
enums
an oddity.
didn't exist.
Yeah.
Apply the correct things. And, oh, that was the wrong thing. There we go. Oh, why are you still screaming? Cannot convert value of unsafe pointer, unsafe mutable pointer in 32 to unsafe pointer in 32. Oh, we just need to do there we go. Let var actual data is the same thing. Right? Or I think it's too early to be trying to make API decisions. We can obviously clean it up as we go.
Well, and one approach I've heard suggested is to write the code in the test rather than write a function call in the test. And then once you've got that working, then you take that code from the test and turn it into a function.
Okay, yeah. That's a way to do it.
It's one approach. It's not necessarily the always right approach, but it's
in out. Oh, why are no wonder that looked weird. Do that so it stops screaming at me. What was the type of this? Save pointer. Width. There we go. Height. So now we can put some parameter names to this. So now we know what we're doing. Width. Okay. And height. Oh, we forgot to pass in a couple parameters. That's what that's about. And there we go, applesauce. I'm just making sure that those also match. Yep, excellent. Now you said we could just create a hash from these?
right. Yeah, the data that's returned.
No. Joe, are you still there?
Joe, do you? Apparently not. You might have to import.
Well, the question is what to import.
Well, start typing sh off of an import line and see what it suggests.
Yeah, I guess that's one way to do it.
Import. No. Try hash. No. Encrypt.
Well, there is CryptoKit, but I don't know if that's what we want. Or crypto.
Probably not. But let me see if I can actually open up the documentation and see.
Yeah.
Apple CryptoKit, SHA-256.
Okay, that's what we want then.
Yeah.
CryptoKit. So.
Andy?
Hey.
We're live and direct.
Live from New York?
Yeah, Marcus is live streaming us.
Yeah, we are live streaming this session, so if you do not want to be recorded, you may want to keep your mic muted or join the stream directly from YouTube.
But if you want to talk, then join in.
Okay, here we go. Creates a 256 hash function. But what do I do with it?
There was one he was saying pass in data to it.
Open in developer documentation. Init. Update. Finalize.
Yeah, sorry, I was having some Discord issues here, but it should be SHA 256.hash. Pass in the parameter.
Okay,
There you go. You just, yep. And then if you want to view it as like a string, then there's another piece you do. So,
but for testing purposes, just comparing expected hash equal actual hash.
I'm not sure if it'll let you. I'm not sure if that's going to work, but I guess maybe it'll do it the right way or as you would expect. Otherwise, you have to do like a compact map across it. So,
well, let's see what happens. Let's just run these tests and let's see if anything happens. I mean,
because it should fail because you're not actually doing anything with your applesauce function yet.
Yeah. Oh, bad access.
What's the deal with that?
We're D data protocol or array of uint 8 instances. Well, well, okay, no, it's a type alias for uint 8, so.
Huh.
Why did we bad access?
Oh.
Can we look at the stack here? Well, that's not very helpful.
You might want to Command-Shift-Y to drop the console so you got a little bit more viewing room. Yeah. Ooh, ouch.
Yeah, no, it looks like we're just in some weird assembly stuff that I'm not going to be able to parse.
Well, didn't see that coming.
Well, it's at line 63 that we care about at this point. That's the stopper. So getting a...
Oh, you know, that's still going to crash even though I changed the expect.
Yeah, the expect wasn't the... Oh, yeah, but that's to be expected because they are not equal. And one of the annoying things with Swift testing is that the assertions will sometimes produce a thread or task crash instead of just an assertion failure if things aren't exactly the way they expect. So you're doing a comparison of an empty array, the applesauce data,
Yeah.
versus the filled array that the original code, the biomesToImage stuff is producing.
Well, wait a minute.
Oh,
No,
except
it
no,
can't
you're
be an empty
initializing.
array. Yeah. Because we're
Yeah,
setting the image.
you're initializing the array.
Yeah, we're
Yeah.
initializing it first. So that shouldn't matter.
Yeah. Huh.
Okay. What if... maybe it's a concurrency problem.
Yeah, that shouldn't impact it because it's just within the context of the test itself.
Okay, there we go. That was the issue.
Test failed.
Because it was... I can't even see
No,
the
but you
error.
weren't.
Oh.
You have no awaits.
There we go. There we go.
You have no awaits.
Yeah.
So the async would make
Yeah.
zero difference.
Okay. Well, clicking on it is a very bad idea because it takes forever to load. Okay. Well, so that worked.
Sort of.
I mean, the test
that
failed
was still-
spectacularly and didn't crash. That's a good sign.
Yeah. Now here would be the thing to do. The data that you're getting from the actual, like your expected data, if you can copy that output and make that what applesauce does. So, applesauce won't be a proper function, but it's like saying, we expect the result to be 1, so we'll make applesauce hard-coded to return 1. That sort of thing as a step to see, okay, can we actually compare the two results?
I wanted to avoid doing that because trying to even click on that darn fix it takes forever.
Well, do a print output, and you can just copy it from the console then.
True, yeah. So here's what we're going to do. We're going to restore our hashes. Are you going to let me? Thank you. It is not happy with that fix it.
That print may or may not work because print is weird, but let's see. Oh, well, that's all zeros. That's not right.
No.
Oh, okay.
Oh, it's all just zeroed out at the
all
end.
Yeah. Grab the thumb on the right because that's like tons.
But if I do that, I would start a whole new selection.
Hold down Shift and click.
Oh, Shift and click? Okay.
Will extend the current selection.
Oh, that I did not know. Okay.
Learn something every day. And then 10 pages of numbers.
Is this what you wanted?
Holy. Oh. Wow.
Is this
So
what
I
you
no,
wanted,
you-
Greg?
you're not-
how you got it to...
You-
How did
you're
you
not
get that?
So go ahead, Joe.
I was just going to say, how did it actually get the hash to properly hash?
Good question.
Don't know.
Okay.
Xcode gonna Xcode.
Oh.
And what you're doing there on line 80, we're not returning from this function. We're assigning the value to the data in out parameter. If, yeah. Ooh, self-destruct sequence. Oh, that's a nice view.
You broke it, Grant. You broke it.
Yeah, wouldn't be the first time. Certainly won't be the last time.
Okay, let's maybe change a few things here.
Yeah, because why does it care about how big it is? I mean, you could do a 4x4 grid, and that would be enough to be.
Yeah, we could do that too.
Because we're not dealing with an actual case. We're just saying, is our function producing the same thing as what would pass into the original C function?
Yeah, it was supposed to be a 64 by 64 in terms of the actual chunk, and then we were scaling it up by 4 to do 4 pixels per one Minecraft block. That's what we were doing. So I think if we just shorten it down to be a 4x4 Minecraft, so like 4 wide, 4 long, and then do 1 by 1, we should have a much smaller output.
Yeah, because when I'm working on the puzzle game I'm doing that's similar to Sudoku, like I do function tests where I drop it down sometimes to a 1 by 1 grid, because just to simplify the testing. I still test the cases where it's like a 9 by 9 grid or whatever, but for a lot of my tests, it's just sort of like, is the basic thing enough? Because if it fails on the 1 by 1 grid, then I don't even need to bother testing the 9 by 9 because I know something's wrong already.
Okay, well, we just did the thing.
Aha!
The Swift testing. Oh, there we go. Now it's back. I think I need to close and reopen this file. There we go. Now
there's the green diamond.
Okay, it does do the thing.
Right. So now we've validated that you can compare when you have the result from the C function and the result from a Swift function, even though the Swift function is just passing in fixed data. So now you can start to actually mess around with what the Swift function does.
Yep. So let's go look at biomesToImage then. Xcode 26 being Xcode 26, go figure. Okay, here we go.
What I would suggest doing is just straight up copying that and pasting it into a comment in your Swift function. And a line by line comment so that you can individually chunk. Yeah.
Bye-bye, data.
Bye-bye.
Gonna run it again just to verify that it will stream.
Yeah, it should fail. Yeah. Okay.
TDD, ladies and gentlemen, TDD.
So you have a couple of integers and then a third integer. So 2 uints and 1 int. Although that int looks like a Boolean rather than a...
I think this is supposed to be some sort of flipping property where it changes the rotation or something. Yeah, it's just a Boolean. Yeah.
Okay, so...
Well, I think we can at least change that. So now if we go here...
Hang on, though. because that if flip, if you're passing 2 in, 2 would be a true value in C, because only 0 is false. So it's expecting it to be true. Like your call to the C function, you're
true.
passing in a true value to it. So yeah, on line 60, it's true. I do not miss working in C. As expected. So now if we go back down, so line 85 and 86, we're defining a few things to work with.
So biomes is false.
And it's actually contains invalid biomes.
Yeah. Apparently
I would have just copied and pasted that. Yeah. Okay, so we have that.
Unsigned int.
Okay,
so
I and J.
So I and J are just used to loop inside of here. So
yes.
What we can do then is we could say for I in.
Well, for J in, because the outer loop is a J loop.
For J in, that would be what? 0.
0 ... less than SY.
SY.
Yeah, okay.
Oh, that's height.
Now, where's SY coming from?
Height.
Okay.
Let me just do this.
Yes.
Oh, you could do it so much faster by doing XYZ. I know. I don't care. I'm doing it this way. Just so we're clear on what's what here.
Yeah.
So we're not tripping up, right? Because, in our applesauce function, we used sensible names.
Yes. Well, which is part of Swift-ifying it, so you can actually understand what's going on in the function instead of SY, like, huh? That doesn't tell me anything as a name. Like, why would you call it SY? But, yeah.
Somewhere around there.
Okay.
And then here is pixels,
Pixels per cell. And flip is still flip.
Flip. Yep. All right. We're good?
Yeah.
I think we're good.
Yeah. Oh, did you get those flipped or? Oh no, right. Yes, that you got it right. It's just that.
Yeah.
In the parameter, it goes SX and then SY, and then the loops it goes SY and then SX.
Yeah. So it starts with the Y first and then the X.
Yeah. So you're initializing an ID.
Yes.
What I would do at this point is cut lines 96 and 97 and paste them at the end of the commented out code.
96, 97.
Yeah, just cut them and stick them at the end of the commented out code. So we have the commented out code inside the loop for now.
Oh, that's going to confuse me.
Well, because this way we can be looking at it in context. So, for example, and this is how I would do it. Maybe it's not the way you would do it, but for example, I would take lines 97, 98 and paste them in front of 93.
Yeah, see, there we go. Now that makes more sense.
Yeah.
There we go.
Yeah, just so that you have that as close to context as possible.
Yeah. Do we modify? Okay, so we do some things. Well, I guess we'll just do let for now, and if it screams that we need to do something
Yes.
later, we change it to var.
Yeah, the classic Swift always start with a let.
Biome IDs. J is, well, we still have J times width plus I.
Yeah.
Oh, cannot convert.
You're in 13. Okay, so we got, type. I think it might be the other way around.
No, it's the I it's screaming about.
Well, then perhaps change the height and width to be the types you want to be working with.
Okay. Oh, the whole thing needed to be an int.
Okay.
That's peculiar. And so what are you now?
Oh, yeah, sure. Yes, because it's just an array index,
Yeah.
a default array index. Yeah. Okay.
So I guess we technically
Yeah, so maybe
need to do that.
Yeah, so make those ints instead of, because they're coming in as probably like cint or something like that.
Making this whole thing redundant.
What's the actual type?
Cannot
width
convert
still.
UN.
Scroll up a bit.
Oh, because we still set these as UN32s up here.
Right. Yeah.
Okay, there we go.
Now, eventually, you may want to change the interface to this function to take ints instead of uint32.
Yeah.
But
that's later.
That comes later. Yes, that's why I said eventually you may want to.
Yeah.
So now we need the RGB.
GB is.
Yeah, you haven't put a type on it. Oh, okay, yes, because you set it as a var, but we know it's going to be changing.
Yeah. Now.
Because right in the next chunk, we're changing it.
If ID is less than 0. No, so 0 is inclusive. Dot contains ID, biome ID. Now give me a second. Can you not Xcode, please?
Xcode gonna Xcode.
Stick you inside.
Yeah, and then you can just get rid of that. Yeah. And that line 114, you might as well uncomment that because that's a comment line you might as well leave in for now.
Okay. So now we got some things that we're doing here. R is biome colors. Now is that, I think we just called it colors. Yeah. Colors of biome ID dot 0. Cannot access.
Well, at 0.
At 0?
Yeah. Oh, because you defined on 104, you defined it as a tuple instead of just 3 distinct variables?
It's an in-out.
No. 104, you defined a tuple instead of distinct variables. Like look at 101. 101 is distinct variables rather than a tuple.
What does RGB have to do with colors?
You're assigning, like on line 111, you're getting the colors, you're pulling it out and you're assigning it to R and then assigning it to G and assigning it to B. So it's its way of pulling the single byte colors out of the biome colors. So 104, you have defined a tuple when what you want are 3 variables. You're not defining 3 variables, you're defining 1 variable there as a tuple.
Oh, I see what you're saying. Okay. Because Swift is stupid. That's why. Because you can't do tuples like a normal person. Well, no, that's still not the issue. The issue isn't that...
No, it's not dot zero, it's at 0. So subscript that. Sorry, not at, subscript. Okay, so, is colors
the issue
biome
is not,
colors?
The issue is not this RGB. The issue is... The issue is this. Because they did...
Okay, well, what does it look like in the original function? What is colors in the original function? Color group. Okay, so that... Yeah, okay, so if we go and look at the original function, is that parameter the same thing that you're trying to access? Because it's access... Okay, biome colors, it is. Oh, it's a pointer.
It's a pointer, yeah.
It's an array of...
It's an array of colors, yeah. So we need to get the ID first to pull out the correct color.
Well, go up to your parameters for this function. Unsafe pointer int 30, what you're passing in there is not an array of tuples, you're passing in a single tuple. So you need to change that parameter to be an array of tuples. Okay, now you should be able to get the subscript 0 off of that.
No, now it's dot 0 because it's a tuple.
Oh, jeez.
Nope.
Okay.
Because biome ID is int32, apparently.
Oh, yeah, array indexing. Oh, yeah, don't worry about that because we just need to do the next lines, G and B. Duplicate that line a couple times. And...
Ay.
Will it let you use variable names in line 71? So, as part of your tuple?
Sorry, say that again?
I was just thinking, would it let you use variable names as part of the tuple in the line 71? So that you don't have to use 0, 1, 2, but less of an issue, I guess, but... Well, sure, do that.
Oh.
You're overwriting the variable? Yeah.
Yeah, so on 104, define the type to be uint8 tuple instead of int tuple. Okay. Whew.
Ay.
Is that given error? Was that assigned as a let? I thought that was a let up there.
Contains invalid biomes? No, it's bool. Or it's a...
Oh, okay, it is a var.
Because we know that we're going to flip it later. Because I think what's going to happen is I should have done this, but... And then all the way down at the bottom. There.
Ah, okay, yes.
Yeah, okay.
Okay, so 118.
Now we're doing some weird stuff.
Yeah, some weird bit flipping.
So we could probably do the same thing that we did here. Well, sort of, because I think we could still do and
Oh,
x 7/2. And then we just need to, we still need to subtract 40 from each, though.
now, is biome ID before it's cast to an int, is it just a uint 8 or is it something else?
In 32.
Ooh. Because we're doing a single byte mask on it. If you look at the C code, what is ID in the C code? What type is it?
Int.
Yeah, so that should be like 16 or 32, depending on the platform. Huh, okay. Weird. Wonder why they're applying just a single byte mask to it.
No, I'm modifying the right ones. Okay, so that's the next part. So we're now doing a thing at the end is...
If it's greater than 255.
Yeah, so we need to do... Yeah, so
And drop it to 0 if it's greater. Yeah. Oh, and then mask it so it's only got the first byte.
Yeah.
Oh, ugly. God, I do not miss working in C.
I feel like half of this stuff will probably get invalidated once we introduce our custom color groups and all that. Because I feel like this stuff should probably already be taken care of when we scan a hex value.
Mm-hmm.
Okay.
But for now, we want to just completely replicate the original function and then improve it. Yeah.
Okay.
I could be wrong, but I think those three lines might not be completely equivalent because
they are not. The end of line 127, you are masking R with the 255 value. It's not returning 255, it's returning R masked with 255, bit masked.
Yeah, I could be wrong, but I believe if the value is under 255, it'll be the value because the bits would be masked together. So if it were 40, it would be 40, but if it were over 255, then it,
Yeah. So
no, never mind. I see what you're talking about now.
If R is greater than 255, return 0. Otherwise, R masked with 255. Yes. G and B. Yes.
I thought you were talking about this. I was like, that doesn't look like a mask.
Oh, no, sorry. Right.
Okay.
Okay, so that's that chunk.
Now we have M and N. Okay, so I think we know what's going on there. Right, because they're both pix scales. So for M in 0 pixels per cell, for N in 0 pixels per cell.
And then a block of stuff.
Int idx is pix scale times I plus n. I think that's the pixel index, right?
Maybe. Maybe just call it IDX for now, but
cannot convert, right, because things. No, now we need it back as a UN32. My goodness.
Right.
Picky. Okay, so what are we doing here? IDX plus equals SX is width times pixels per cell times, my goodness, pixels per cell times J plus M. Else, it looks like you're doing the same thing down there, but something else.
With a little bit of a change, yeah.
So now we need to group U to be height minus 1 minus that.
Yeah.
Okay, so now we have unsigned char pix.
So that's a byte array.
Yeah. Where did pixels get defined? Is that a thing we're passing in? No?
That's the data. Wait, it was up there.
Pix scale.
If you go right to
Oh, never mind. It's data. Okay.
Yeah.
Data at 3 times IDX? No. Wait, no. It's like this. But that doesn't make sense. So what are we doing?
Okay, so what Pix is doing, because on the next 3 we're extracting bytes.
Yeah, we're setting the
so
colors.
That it is a byte pointer. A car is a single point in it is a single byte in C. So that pointer, it's getting a pointer within the pixels, offset by 3 times index. So you're trying to find the byte at. So if data is a byte array, an array of bytes, then you're trying to get the at position 3 times index, you're assigning the value of R, and then at the position 3 times index plus 1, you're assigning G, and so on. So that on that line,
oh, I see what
you don't need the var
yeah.
pix equals. You don't need the var pix equals, and that and then plus 1 plus 2. No. the +1 is outside the parentheses because you're multiplying data 3 times index, and then you're adding 1 to it. And then adding 2, yeah. Okay, yeah.
Okay.
And that should be doing the same thing as what that C code was doing.
I think that's all of it.
I believe so, yeah. Might as well run the test and see what fails. You don't need to run the whole suite. Yeah, just the single file will do.
Test succeeded. We did it.
Okay, we can go home. Ship it.
Ship it.
Now,
let's clean it up.
I would suggest the next step, well, first of all, you probably want to commit. So you've got this saved in its current state. But the next step would be to try to figure out the meaning of those poorly named variable names like I and J and M and N and so on. So figure out good names to give those so that it's easier to understand what's actually going on in that function.
Stage commit. Okay. So we got that. All right. Now I think we can start collapsing some of these.
Sure.
Because I want to be able to better see what it is we're actually looking at here now.
Yeah. Yeah, and I mean at this point you could even probably delete most of those because we've proven that we did what they covered.
Yeah, I think I'm going to do that.
Yeah, and you have them committed in the repository if you need to go back.
Now, if I had relative line...
Oh, maybe keep that part. Just that name mapping, but the rest of the stuff.
I mean, I know the test worked, but can you have the code go ahead and use it real quick just to make sure that it does?
That's a good point.
I can't because we're in the tests right now, and this is only going to run in the tests. We would need to have it move over. And that's going to
Okay, so maybe that's the next step. Maybe the next step is move it over, and then we can worry about cleaning it up.
Yeah.
Oh, that thing you just deleted on line 100? I think that was the comment. Yeah, that was the comment that you wanted to leave in. The one you just deleted on 100. Yeah.
Now condense this all the way down to a single compact map statement.
Yes.
Yeah, well, the problem is I don't know where I want to put this, so...
Well, make a new struct. Or make a new enum if you just want to have it namespaced. And if you want to attach it to something else later, then that's fine too. Yeah, with the WTF barbecue. Okay.
I mean, at this point, I wouldn't care about what it looks like right now until I have everything cleaned up.
Make it a static func so it can just be accessed. Yeah.
We're gonna
change what the test calls. Yeah.
Well, we're not going to be able to run it in the library because this is the library, not the app. So we're not going to be able to see this anyway.
But you had a demo app going using the library, right?
I have to go through the whole thing.
Does
this make you happy, Joe? Does this make you happy? I have to
see
go through a whole
results.
song and dance. Oh wait, this still isn't going to even run because we only call it in the tests. We only call that.
Yeah, you
in
need
the
to actually
test.
change what the library calls
Yeah.
instead of calling the biomes.
Yeah, so that's not going to even work. Ugh.
Where is that biomes call? There we go.
All this just because you wanted to see it first.
Oh, all the parameters are named, so fix might do it. Sometimes Xcode's fix function off the warning will work in those situations.
I don't trust it.
Well, that's why we have Git version control, because if it breaks something, you just roll back.
There. Close out of Xcode. Reopen Xcode. Because if I don't do this, it's going to scream and be like, oh my god, there's no such package.
No? Oh, there we go.
Does this please you?
Pleases the
Joe,
court.
you better exclaim. You better exclaim your pleasure.
Oh, it's wonderful.
Everything's coming up roses.
Okay. I mean, I could already tell because we wrote a test that says, does the data match? Yes, we're good.
The slight concern I have there, if you go back briefly, if you're willing,
Go back to where?
is that width there says length and height there says width. I'm assuming that's the way it was since you only added argument labels. It just stood out.
Yes, things are kind of backwards in some of this stuff. The X, Y, and
Yeah,
Z
because
are
the
not
thing
where you would
is,
expect them.
because the thing is, this is not passing in a rect. We have to switch them over to this because width and height is image width and image height, not Minecraft with Minecraft height. So this length is saying the length along the x-axis. The height here is length or the width along the z-axis because in Minecraft, y points up, not z. That's why it looks weird. That's not a decision I made. That's not a decision Cubiomes made. That's a decision Mojang made when they made Minecraft.
So what could be done here for clarity is, and we won't do this right now, but in front of this, we could initialize a couple variables that have the names that explain, you know, this is why length becomes width and width becomes height. Yeah. But you're right. That is very confusing nomenclature.
Okay. Let's try to actually clean this up now.
Yeah. So the variables that, you know, we've got J, I, RGB, even though they're single letters, they're clear. Red, green, blue, everybody knows that who's dealing with color
those are
spaces.
fine.
M and N, I and J, IDEX, the index short form, that could do with a little bit clearer, like what is it an index to?
Yeah.
You know, so those things can be clear. And then after we look at that, we can maybe go and look at the parameter names. But this is an index into the data, the block.
No, I don't think this is
index.
the block. I think this is the actual pixel.
So
yeah, this is the pixel.
Pixel matrix index or pixels index, or what makes the most sense to you? Since you know this better than any of us.
Pixel index. Width, pixels per cell, J, M. Okay, so I think, because this is width, this is height. So this would technically be X, this would technically be Z. Okay.
Oh, okay. Or Z position or something.
I think that's kind of redundant. There we go.
Okay, so that leaves M and N.
Now we need to do M and N. So one of them is row, one of them is column, but I don't know which one it is.
So on line 53, we're using M, and same with 55. Oh, and on 51 is where N is being used.
Yeah.
So the pixel index is the pixels per cell times the X, the block X, which X we're looking at, plus N. So N is probably the column offset.
The column offset, okay, yeah.
Is my first guess. Let's, before we, okay.
No, what was it you were going to suggest?
Well, let's see if that means that M is the height, because it's not entirely clear that that's what's going on, or the row position. So on line 53, where we're using M, the simpler form of M, width times pixels per cell times the block Z, and Z is what translates to the height, right?
Yes.
Plus N. Yeah, so that's probably the row. Yeah, so N as column, M as row is what it looks like. I wouldn't swear my life on it, but that's what it seems like.
Okay.
So I think we've got those names down. Do you want to run the test again just to make sure that with all those name changes, everything's happy? Okay. Didn't break anything. So now you can start to look at it and do as Joe was talking about, make it all a compact map.
Good God.
No.
Yeah, so many for loops, man. What is that? So
there's four for loops going on there.
That's crazy.
Yeah, plus some if conditionals thrown in for flavor.
The kinetic complexity is off the wall. It's the charts.
Yeah, so I think what we could probably do is break this down further into sub things so it's easier to follow.
Sub functions.
Yeah.
Yeah. Yeah.
For now.
Nice and descriptive. Yeah. There's no question what you're talking about with that.
Yeah. Okay. So what we're doing here is biome ID, and then we're remapping these to just create colors. That's what it looks like we're doing here, right?
Yeah.
You're extracting the color for a pixel. You're getting that RGB.
So I think we can move.
So that could stand alone as a function.
Yeah. This I think we can move into its own thing here. Now, are you going to be nice? No.
No. Sorry. Is biome ID used after that block? I don't think it is.
Okay, you suck.
No. So biome ID should travel with those
yeah,
lines.
so
The line 33 to 48.
yeah. So we're just gonna have to write this manually. Func color at block X. I think we have these as ints, right? Yeah.
One of the tricks that I do with this stuff when manually extracting a function like this is I copy the code that I'm extracting without assigning any parameters or return value, and then the errors that the compiler gives me says, hey, you haven't defined block X, you haven't defined block Z. That tells me which ones I need to pass in as parameters.
Right. Thank you. Okay, my goodness. We're not mutating it at this point. Okay. At block X. Okay, so it's going to be unhappy because we still need a few things.
Yeah.
Oh my god, I cannot spell.
What? Oh, okay. Yeah.
What is the type of biome IDs? That.
Unsafe pointer int 32.
We're still going to have to clean that up.
Yeah, that's fine.
Static func contains invalid biomes is true. We're going to need to return a couple things.
Yeah. I need to step away for a minute or two. Back shortly.
Colors. Oh, we need to pass in the color table too. Okay. My goodness. That is you. Okay, well I can already see where we're going to be making improvements. I can see it happening. Well, actually, this seems kind of silly. result. Okay, cool. That did something. So we have gotten somewhere, and the test run successfully, so that's still fine. And of course, just for you, Joe, we're running it.
Hey, if you must, yeah.
What did I miss? Oh, you're running?
Yeah. I mean, I ran the test. I already know it's
Huh?
fine, but...
Yep. Proof is in the pudding.
And it looks like this time I didn't have to restart Xcode, so I'm guessing whatever bug was there got fixed.
Ah, nice.
Great. Yeah, so we just created this...
So this is that new color function?
Yep.
Okay. A personal thing, on line 68, you're making block X at, and I would just have it as block X, yeah, just so there's no confusion.
Okay.
So what are the opportunities to tighten that up?
Block X, block C, block Z, width, biome, color. Okay, well, at this point, we'll eventually want to drop
Yes.
the pointers. And I already have replacements that we can use for those. So I think the next thing we want to do is handle this part. For pixel index.
Yeah, that's...
Just trying to think what this is doing here. I think it's just assigning the pixels.
Yes, it's writing the colors to the output.
Assign a pixel, so we need
50 to 59.
I might just snag that. So we need pixel.
Alternatively, oh no, this is still good.
Row, I think, is what?
That was an int. It's coming from the loop. Oh, so whatever pixels per cell is. If you do,
Goodness, why are you? There we go. uint32. That was.
Huh?
I might as well make these uint32s. And then we need data, which is
an in-out.
In-out. Okay, so let's...
Oh, and flip,
Yeah.
which is a bool.
Cannot find...
Oh, your RGB.
Ah, yeah. We also need... which I think... What was pixels per cell again? uint 32. Okay, now we need width and height.
Boy, you need almost everything in that.
Yeah. Are you happy? You're happy. Great.
Now that needs...
My goodness. Well, actually, take that.
Yeah.
Build. Cool. Test.
Testing. 1, 2, 3.
Great.
Okay.
Dun, dun, dun.
Yep. Okie dokie.
Cool. We validated that.
Validated it.
Validated it. It.
Your test suite for Alidade can be called Validade.
Validate. Oh my god.
Sorry. Actually, I'm not sorry. I enjoyed it.
This is a sight to behold.
Something I'm thinking about, that whole thing with flip. Anytime you're passing in a Boolean to a function to change its behavior, suggests that you might want to split it somehow into two things.
Yeah.
So it's not, but yeah, this is kind of big and ugly.
The whole thing's just big and ugly.
Well, yes. Anyway, not something necessarily to deal with right now, but something to have in the back of the mind.
Yeah. Now, I'm going to commit what we have real quick.
Sure.
So
Good call.
That's color slope.
Commit early, commit often. Oh, do you want to add Andy to that? Wah, wah, wah.
Andy, give me
Andy, do you want to be listed?
Sure, it's up to you.
Maybe in the chat, drop which email address you want used. The one that links to your GitHub account.
Yeah, get name and get email. I was going to say addresses.
Okay, it's in the chat.
Thank you. Dun, dun, dun. There we go. All right, commit. Okay, now, bye-bye biomesToImage. I don't need you. Now, I want to point this out. We do have two other structures that I wrote in earlier this week. Color map, which maps a biome ID to a color. And then an actual color struct, which contains red, green, and blue. So I'm thinking we can rewrite some of this. So instead of doing all this weird pointer hokey pokey, we can just use these actual raw Swift types.
Yes, please. I mean, ultimately, getting rid of all the, unsigned C mutable pointer stuff is where you want to get with this.
What I want to do then is I want to modify our test here. So we'll keep the expected stuff as the way that it works for now.
Right.
So the only thing that we need here is we need to just replace this part, the color grouping. So what I want
in terms of what's getting passed into applesauce. Yeah.
So now we need to create our color group. So we need and I think all we need to do here is just say let actual color group is Minecraft biome color map dot decoding pre-filling. I could have sworn I had a default.
You had one there. You had a dot color
dot Cubiomes default. That's what I want.
Oh, okay.
Dot Cubiomes default. And if you're wondering what this does the exact same thing.
Okay.
As this does the exact same thing as in
what you were getting for
colors here. I literally took the C code, copied and pasted it, moved a couple of parameters around.
Yeah. Yeah, totally.
So now what we can do here is we can change a couple things around.
Yeah. Down in applesauce.
Yeah, so down in applesauce, what we want to do is I think we want to change this out for the lookup table.
Yes. And instead of an in-out, it's just a straight up pass it along.
Actual color group.
Yeah.
Biome IDs we still need to leave.
Right, yeah, yeah.
So let's go back to...
This is just the colors that's being changed.
Still called... What the fuck is this? I don't know. I forgot I didn't change the file name for that. Minecraft biome color map. So now, when we go here, we'll jump to this.
And that...
Let biome ID...
The color LUT.
Yep. So we need to go here to the color LUT.
On line 73.
And we want to say... Oh,
you haven't replaced 73 yet.
Yeah.
Yeah.
That would do it. Okay, so now it's screaming. Color dot color LUT dot color for
biome ID.
Biome ID.
Yeah.
Cannot convert color
and what,
RGB to type uint a...
Okay,
I
right.
know what we need to do here. Yeah, this is
Yeah.
a quick fix. This is a quick fix. For
RGB color
Yeah, we
equal
need
color
to
dot
do-
color.
this, and then result dot color is color dot red, color dot green, and then later down the line we can change this so we're using the real
Right.
color RGB and not this weird hokey pokey.
You're now doing color dot. You got blue and green backwards. It's
I did it
RGB,
again.
not RDG. Yeah.
I'm thinking of the old Supreme Court. That's what's happening there.
Notorious.
Why is biome ID? We need to create a Minecraft biome from this raw value. So we just need to do the same thing here.
Well, and
No,
something
not
that
quite,
I
not
would
quite,
I
not
would
quite.
suggest doing is before you go too far along on that, lines 79 and 80 ideally should
Yeah, we can move this
have the
around.
logic that is in lines 82 to 95 there, which just moves, so my numbers might be
So
off.
we need to just...
So ultimately, yeah, and then
Bye-bye.
well, what I was suggesting is lines 86 to 96 there, that the smarts about that should be in the Minecraft biome color map. So it knows if it's being passed something out of range, contains invalid biomes,
Yeah.
and it returns a null or an all zeroed or whatever result. Some way, maybe you set it as an optional return, and if it returns a nil, then you know that it's invalid. Or something where, because this knowledge here about mapping colors, that should be in the Minecraft biome color map. It shouldn't be in your...
Yeah.
I mean, ultimately, frankly, this biome color function should probably be a function on Minecraft biome color map.
To some extent. To some extent, because we still need to provide like an index and stuff into it. But yeah. Well, we just gotta keep.
Oh, yeah, I see your point. Yes, yeah, because you're finding, okay, what point in the map, and then you're asking
then
the color
we're
map.
asking.
Yes, right. Yes, okay. Yeah, because you need to get that biome ID
Yeah,
out
we
of
need to
it.
get
And
the
once you
biome
have the
ID,
biome
then-
ID, then you're calling the color map with the biome
Yeah.
ID. Yeah, okay.
Well, wait a minute. Hold up. This is just manipulating the color, right?
Yes, but it's not just manipulating the color. It's checking, is the color out of range?
Right. If the
And
color's
if
out of
so,
range,
it zeros.
Okay. Yeah.
Otherwise, it clamps it to a single byte.
Maybe you're picking up what I'm putting down here. Maybe you're picking up what I'm putting down
Maybe.
here.
Are you picking up what I'm putting down?
I'm being ridiculous with this. Whoop.
The blue.
Now, if 0 We did 0 to 255 in this, right? No, we did 0 to 256. Shouldn't it be 0 to 255 technically?
It should probably, yeah. Yeah. Well, 0 to less than 256 is...
Yeah, 0 less than 256 would be correct as well.
Well, same thing. But yeah.
It's the same thing, yeah. Okay.
Yeah.
If
you might need to go look at what the other thing was.
return self.
Oh, okay. Yeah. Yeah, gotcha.
Oh, why are we doing this? Oh, because we need to make.
Oh, you need and.
No, it's screaming about initializers because we need to make these uint 8s.
Oh, okay.
Commas can still work for conditions in the particular case that we're doing here.
Okay. Right.
Okay, so if all those contains, we're going to do that. Now,
self is immutable. So, yeah.
Or GP.
So, okay, what you're going to have to do is... Oh, okay. Okay, so, oh yeah, we're returning a new instance of this struct type. Okay, yes, we're not modifying the existing one. Okay,
that is what.
Gotcha.
Otherwise, I would have marked it as mutating.
Yes, yeah. Because we're in a struct, not a class. We got no class today.
Return. Now, we can go here.
Result color equal.
Right, because we still have... Yeah, we could just say is result color... Oh,
clamped.
No. We need to do color clamped. And then we need to do... Oh, no. Wait, hold up.
Yeah, make a new line for...
No, wait.
Color equal color dot clamped.
Yeah.
Not result color, but color equal color dot clamped. You don't need a new color. You're just clamping color itself. And it's declared as a var up on 78, so you can replace it with its color, with its clamped self. Bob's your uncle.
Okay. Now...
Run the test.
Wait. Okay, that's fine. Now, is there anything else that we need to do before we run the test here? Because I need to check to... Okay, well, no, we extract the color down there. That's fine. Oh!
Oh, haven't changed that over yet.
Yeah, that's... We can just... Biome colors. Oh, no. We just need it. Well...
Where were you initializing the...
Hold up. Give me a second.
color table.
Yeah, we just need to say this. What? No, it's get. Technically,
Had to step away for a phone call. I'm guessing you guys are cleaning up here.
Yeah, we're continuing to clean up. We're using our own color map instead of random uint8 nonsense.
Yeah, basically trying to Swiftify all the things.
Okay, all the tests pass.
You're going to keep doing that every time now.
We gotta keep Joe happy. Oh, failed to generate the natural color biome map. Operation couldn't be completed. Decode error 1. This is failed to generate the natural color biome map. Why'd that happen?
Well,
that's
something in that function, because we changed the
return. Let natural color file. I mean, you should be fine though. Logger.warning. Okay, so it's got to be something inside of here. So error 1 is invalid line arguments, probably. Or invalid biome ID. Oh.
Right. Yeah, because if it's 0 indexed.
The operation could be completed. Decode error 1. Okay, well, here's what we'll do. Because that's not related to what we're doing. That's
okay.
That's my own code from a while back. Though it looks like it's still using the... Oh, wait, no, this isn't the natural one. But hey, at least
these colors are different than what we've been seeing before. Oh, maybe it was a different position.
No, it was because there was a bug in the way that I wrote the thing I did, so sometimes you'd see black pixels where there shouldn't be.
Oh, okay.
Because I was working on this color mapping stuff. But yeah, you could see that now we're using our color map that we defined.
Caching looks like it works better on that one. Is that actually caching?
No, it's just using the exact same things as the regular one.
Okay. When you were doing that struct with all the color stuff and you had to do the RGB bit mask with F or 255, that seemed unnecessary. Like
the bit masking?
Yeah, why
63 to 65?
Right, because if it's greater than 255, it's 0, but that means it's less than 255. So a mask would just be exactly the same value that it already is, right?
Yeah. That is. Huh.
I mean, hey, it's just one operation, but it's still, it seems unnecessary.
I mean, maybe there was something that Cubiomes was doing really weird, and they had to do this. I don't know.
Okay.
Yeah. Well, and the thing is, this is, if, like on line 65, if red is greater than 255, so it's more than a single byte value, then make it 0. with these, if any of them are less than 255, they will get their regular color, but the red, if it's greater than 255, will be zeroed out, and you'll end up with a weird color. Rather than just saying, hey, if any of the colors are outside of the acceptable range, just zero the whole thing out. This isn't zeroing the whole thing out. It's only zeroing out one of the color channels if it's above and the others are still below 255, then they're fine.
Yeah.
Like that's kind of weird.
I think it's like if it's out of the color range, move it back in so it's in the color range.
Yeah.
Not just straight up make it black or straight up make it white.
Yeah. Yeah. And what I would be, my first thought on that would be to just get the modulo of dividing it by 255, so that it's not just, red goes to zero always, because it's, yeah, anyway. I mean, I would either say take everything to zero or, modulo as the clamping instead of just force it to zero.
What's the data type for the new red? Is that just a uint as well? Or?
They're all uints. Because we're taking the current color here and we're just creating a new one.
Yeah, but at this stage, they're uint 8s, aren't they?
Yeah.
Like, well, no, like option tap on red. Yeah, they're already uint 8, so there's no way for them to exceed 255.
Right. So 66 to 68 is completely useless. Like.
Yeah, I guess we don't even need to clamp them because they're already going.
Yeah.
To
well, there's the minus 40, so I don't know what that's doing, but.
That's some really weird stuff that maybe.
That was a memory leak issue. Somebody was probably like, sometimes it gets garbage, so let's reset it just in case.
This may happen for some intermediate layers. So maybe there's some weird intermediate layer thing going on that was happening.
Except by the time it gets to that function, those values are already constrained to uint 8. They're already single byte values. So there's no way for them to exceed 255.
So I guess we don't even really need this.
I mean, you could put an assert in there, I guess, but I'm not really sure that would ever get.
Yeah, well, no, because
if it's a uint 8, it can't.
Yeah, in our color lookup table, it's already going to return back a color RGB in which the values are already going to be this, right? If they're not valid, if they're not valid here, it's going to try to parse the string anyway. So if we go into here, right, we're already doing a whole bunch of stuff where we're masking out and making sure that we have the correct things here.
Yeah. And I think part of the problem is that in C, they were dealing with, how C's type system is really interesting. And so they could, because they're passing some stuff around as ints at points, it could end up with a value exceeding what they want. So that's where they were applying that clamping. But because we're using a strongly typed language in Swift, we don't need to do that clamping. As soon as we're looking at one of our colors from our Minecraft biome color map, we know it's a safe color. Like it is already like 1 byte per channel, 1 byte per R per G per B. So we don't need that extra sort of safety check that is happening in the C language because we're in this strongly typed thing. We know it's a good color. Oh, and now we're not mutating color.
Yeah, so I can change that to a let in just a second. I just wanted to run the tests again.
Yeah. Yeah. And we've already now simplified the code
Yeah.
by using smart types.
Yeah, so now we just need to take care of this biome lookup table thing as the next thing, and then we should be...
I'm going to call it a day for my part here, because we've been at this for about 2.5 hours already. But do feel free to carry on. Thank you for hosting us today, Marcus.
Yeah, not a problem. It looks like the crowds have gotten smaller, so I think we can call it here. I'll probably do some more cleanup on my end,
Sure.
just so the API call site's neater, and then the next time we can revisit. You can revisit the parallelization, because I bet we could probably clean up these loops.
Yeah. We've now, now that we've got some clarity on what's going on in those loops, things have some meaningful names. We've pulled things into meaningful sub-functions and so on. Can now say, okay, here's some stuff that can be split out into parallel tasks. Yeah. Now, won't be next week, because next week the iOS Dev Happy Hour is happening.
It's not going to be next week, because next week is the happy hour, so I won't be hosting it. That's why I said next time, not next week.
Yeah. I was saying, in terms of scheduling, whenever you want to schedule after that, I'll let you do that. You can create an event on the Discord server. And
yeah. So for the folks that are watching this on YouTube, stay tuned for when I put up the next stream. That'll tell you the date and time in which we're doing it. Likewise, you can join the Swift Dev Chat server if you want to participate in any of these and or keep up to date with the events that way. And yeah, I thank everybody for coming to this session and watching, and we will see you around next time.
Cool.
All right, take it easy, everyone.